This is a transcranial Doppler machine. It's a medical device that, well, the name should give you a pretty good idea of what this does. It operates on the same basic principle as a Doppler radar. It generates a frequency, measures how it bounces back, and then a trained operator can take that output and use it to ascertain something. The transcranial bit, well, that's where it's supposed to be used. Instead of measuring things hundreds of miles away, this is designed for perhaps the most precise application of all, the brain. The transcranial Doppler is used to find blood clots in the brain. So why am I showing you this? Well, something has to take the analog signals gathered from the probes and then turn that into data. And then from that data, generate a graph, generate a report, maybe print something. And that something is a computer. The probes for the testing plug in here. That's where I would store my probes if I had them. But that's not the interesting part of this machine. The interesting ports are all on the other side. You know, some of the ones you've got here, parallel, serial, VGA, there's a lot of stuff with those ports on them. But USB, Ethernet, and probably most tellingly, two PS2 ports, specifically labeled keyboard and mouse. When I saw this at auction, I knew that there was undeniably just a computer in here, just a regular old computer. So of course, I had to bring this home and find out exactly what's going on in here. And not only is there indeed, yes, a full, tiny, late 90s computer inside this rather unassuming box, it's also a way weirder and more interesting computer than I ever could have imagined. This is the DWL Easy Dop, the first edition of it. There's almost no details about these online, barely even a mention of their existence, because it's old and it's an extremely, very niche product. Looking at our serial number, these were clearly made in very, very small quantities. The serial number is 73 on my unit, and it only goes up to 4 digits, indicating that they really never intended to make a whole lot of these to start with. So they're not going to design a whole custom motherboard just for this one unit. But with these being niche and also in possibly the most important field of all, that being the medical field, what's in here has to be guaranteed reliable and work for a very long time. That's why I'm just now picking this up in 2026 at an auction. This was probably used constantly for over 25 years and only retired a quarter century later when something finally gave out. Before I take it apart, though, I'll give you a listen to what this sounds like and let you guess what's in here. You get the faint but unmistakable sound of an old hard drive spinning up, and just a regular post beep like any other 90s computer. Its big metal shell comes apart rather easily. The top case is just held on by 4 screws in the side. And once those are out, the screen should start to come off. It's pretty heavy because it is a cold cathode backlight. And there are a lot of cables in here you gotta be careful with. So I'm going to unplug all of these. All right, and now time for the big reveal. What weird little computer could possibly be in here? It's a tiny Pentium MMX single board computer. Now, I was expecting, based on the form factor of the machine, that it would be some kind of weird ITX board. And in retrospect, of course not. You couldn't fit an ITX board in here because you need the hardware for the whole, like, transcranial doppler part of the machine. So it requires huge DC to DC converters for generating high voltages. And it requires an absolutely immense amount of circuitry for each probe. Analog to digital and digital to analog converters, all from analog devices. You get a sea of microchips on each connector, all serving specific purposes. So there's no room for a whole ITX motherboard. It has to be something way smaller. And that something way smaller is something that I didn't even know existed. I had no idea it was possible to make a single board computer with a Pentium MMX at this time. But wait, Pentium MMX? This came out in 2000. Why choose the Pentium MMX? By 2000, there were oodles of ways to get Pentium MMX performance in a much smaller and more efficient package than this, an actual Pentium MMX. Now, I'm not talking about weird RISC processors or primitive ARM CPUs with software libraries that you could count on one finger. No, I mean x86 drop-in replacements for this chip. AMD's Elan series, VIA's extensive catalog of low-power x86 chips. That was kind of their whole thing. Or what I would think would be the best choice. The Geode series were based on the Cyrix Media GX, arguably the first APU. The Cyrix Media GX in and of itself is based on Cyrix's Socket 3 586 clone architecture, but the Media GX had onboard graphics processing and audio processing capabilities. And therefore, so did the die-shrunk, very low wattage Geodes. As it has speakers and a screen, as well as, of course, the CPU, this system needs separate graphics and sound processing chips in addition to the absolutely massive MMX CPU that takes up so much space. A smaller package that's lower wattage and combines all of those elements seems like a super obvious choice that I can't quite fathom why they didn't go for. However, I didn't design it, and it's really cool, admittedly, to see a Pentium MMX in something this tiny. So I'm gonna shut up. All of its I/O is over giant pin connectors, because there is literally no space for ports on this board. Everything is so absurdly tightly packed that there's not even space for anything other than headers. So I want to be very careful taking this out. And under it, well, that's that hard drive that you heard. Down here is a Fujitsu MHK 2060 AT, a laptop IDE hard drive. Now this one still works, and I'm gonna boot this system up pretty soon and show you what the software actually on it is like. But for now, let's just talk about this motherboard. It's barely larger than a Raspberry Pi. Got one for reference here. Here's a Raspberry Pi 4 in its case. And this is only like 33% larger of a board than the Raspberry Pi is. Now, I'm going to call this a single board computer. That's debatable because the RAM is on a separate module. This is standard just SD RAM, by the way. This is PC66, 4 meg by 64. Quick interjection here, that's 4 megabits times 64. And that's 256. When you convert that to megabytes, that's 32 megabytes. This Intel chip is not a North Bridge or a South Bridge for the Intel CPU. That's in fact the Ethernet controller. It's TIN 100. On the back, in what looks like a RAM slot, but I can't tell exactly what it is. Maybe it's mini PCI? It doesn't, no, it's not. I don't think this is any sort of standard interface. If anyone recognizes this slot, I would love to hear from you. But anyway, this is what connects the graphics on the board to the LVDS of the display. And I assume this is for if there's a touchscreen, but that doesn't apply here. On the back, these two ALI chipsets are the system's, well, chipset. And this chip is the graphics. This is an M69000. And it's actually a pretty fairly powerful graphics chip. And it's a little bit overkill for what this system is doing. This is actually a smaller, later die-shrunk version of the M69000 that has VRAM on package. So none of the graphics memory is shared from the system's main RAM. This has its own... It has its own couple megabytes of VRAM on package, and it stays very happy because it gets its own lovely little memory. Let's put this all back together. Now, this motherboard was made by a company called JumpTech. So, I won't call it off the shelf because, I mean, you can't just go into a store and buy some weird shit like this. But it doesn't appear to be made specifically for this unit. This is, although it's a very uncommon and strange form factor, this actually is a common industrial tiny PCB form factor. They're designed to be stackable on purpose. That's why this motherboard, in addition to its male pins on the bottom, has a massive row of female headers up here for if you've got more shit you want to stack on top of it. A lot of these boards only have the I/O on the bottom. This one has serial, that might be USB, that's parallel, that's the IDE, that's something else. So it has a little bit of extra interface on the sides that not all of these boards have, and I've never seen a board this tiny with a CPU this massive. The size difference is utterly wild. But yes, although it's not unique, like a board this small and this old, I mean, to this particular unit, it's absolutely fascinating to see a full-size Pentium in something this small. Well, that's the big secret. That's what we were all waiting for, I suppose. All that's left to do is to power it up. But you saw earlier when I turned it on, this screen didn't do anything. That's because, as you can tell from the inverter here, it uses a CCFL backlight, and the CCFL backlight is completely cooked. That's kind of to be expected. With the use a device like this would have seen, it's completely unsurprising that the backlight eventually gave out. Luckily though, and because the system does have VGA output, we can just plug it into a monitor. So I can show you exactly what this system has in it and exactly what it's doing. And yeah, there you go. There's your 166 megahertz Pentium MMX. And okay. That went way too fast for you to see. And I guess I put the IDE connector on wrong. When I snapped it down onto the board, I put it over the wrong pins. I really need that that plastic part around most IDE connectors to guide me. Anyway, yeah, there's our 640K, standard RAM, all that, starting MS-DOS. So this is just an MS-DOS application, essentially. And there it is. There's its little software, and so there's its little interface, and it's super cool. I don't quite know what all of this means. Actually, I more than don't quite know. I don't know a damn thing about what this means. I mean, some things are just self-explanatory. Depth. That's how far into the brain you want it to scan. And then print and save, well, that's what the parallel port and the hard drive are for. Now I'm going to set this down on the desk and I'm going to plug in the knobs here. One of these is an analog knob. The other is a rotary encoder. I've got my wireless USB keyboard plugged into it. And when I tried this earlier, it didn't support. Yeah, okay, it's PS2 keyboard only, and I actually don't have one of those right now, so I can't get into the BIOS, unfortunately. However, yeah, it just doesn't support USB. Whoa! Oh my lord. Okay. With that plugged in, it's sensing something now. I couldn't possibly tell you what this is picking up on. Some sort of interference, I would assume. I would assume all of this circuitry is exceptionally sensitive to like analog interference, and without having the probes plugged in, I can't tell you what it's picking up on. Since I, of course, didn't get this with the probes. But anyway, the Dresschalter, the rotary encoder, is used to switch what you're clicking on in the menu. And the middle of it clicks, though it doesn't seem to work. So that's how you would go through the menus and select exactly what you're attempting to work on. You'll notice that a lot of these things do have like PC keyboard labels on them. Like, for example, menu, that's M. Freeze is space. Again, without a PS2 keyboard, I'm incapable of fully testing it. However, I mean, that's what the PS2 keyboard and mouse are for. You could just plug those in there. Again, I apologize that I couldn't find any manuals or any documentation about what this actually does or how to use it. When I turned my chair, when I turned my chair and moved away, the output on the screen changed. I'm gonna walk somewhere else. Okay, it seems when I got further away from it that time, and when I pushed my camera away, what was displayed on the screen changed a good bit. So it's probably just picking up on digital interference from my wireless microphone or from the camera. Anyway, again, yeah, there it goes again. I'm sitting nearby and it's peaking. Oh, okay. Guess there's something horribly wrong with my brain. Anyway, I have to wrap it up for now because unfortunately there isn't much else I can show you without knowing how to properly use the software and with the screen and controls being broken. That's why it was pulled out of service, I mentioned. But it's so cool to see that under the hood, this is just standard PC hardware in an absurdly tiny form factor that's just running MS-DOS with this tiny little lightweight application on top of it. So, although it's not particularly useful to me in its current form, the computer in here provides ridiculous upgradability options. So you will be seeing it in the future. But anyway, thank you all so much for watching. And massive thank you in particular to my Patreon members that make me going out and buying weird stuff like this to show you possible. But yeah, that's it for now. Got a lot of other videos on weird old tech if you're interested and want to go check those out. But thank you everyone so much for watching, and I hope you have a lovely day.